The chemistry of oxidation-reduction reaction is not limited to atoms of an element changing to ions or the reverse. Some redox reactions involve changes in molecular substances. Determining oxidation numbers. The chemistry of oxidation-reduction reactions is not limited to atoms of an element changing to ions or the reverse. Some redox reactions involve changes in molecular substances or polyatomic ions in which atoms are covalently bonded to other atoms. This process involves neither ions nor any obvious transfer of electrons. In situations such as the formation of NH3, where two atoms share electrons. For the purpose of studying oxidation-reduction reactions, the more electronegative atom is treated as if it had been reduced by gaining electrons from the other atom. The less electronegative atom is treated as if it has been oxidized by losing electrons. On page 641, follow me as I read to you the rules for determining oxidation numbers. 1. The oxidation number of an uncombined atom is 0. This is true for elements that exist as polyatomic molecules such as O2, Ci2, H2, N2, and S8.
1.
Rule number 2. The oxidation number of an monatomic ion is equal to the charge on the ion. For example, the oxidation number of a Ca2 ion is +2, and the oxidation number of Br negative ion is -1. Rule number 3. The oxidation number of the more electronegative atom in a molecule or a complex ion is the same as the charge it would have if it were an ion. In ammonia, NH3, for example, nitrogen is more electronegative than hydrogen, meaning that it attracts electrons more strongly than does hydrogen. So nitrogen is assigned an oxidation number of -3, as if it had gained 3 electrons to complete an octet. In the compound silicon tetrachloride, chlorine is more electronegative than silicon. So each chlorine has an oxidation number of -1, as if it had taken an electron from silicon. The silicon atom is given an oxidation number of +4, as if it had lost electrons to the 4 chlorine atoms. Rule number 4. The most electronegative element, fluorine, always has an oxidation number of 1 when it is bonded to another element.
1.
Rule number 5. The oxidation number of oxygen in compounds is always -2, except in peroxides, such as hydrogen peroxide, where it is -1. When it is bonded to fluorine, the only element more electronegative than oxygen, the oxidation number of oxygen is +2. Rule number 6. The oxidation number of hydrogen in most of its compounds is +1. The exception to this rule occurs when hydrogen is bonded to less electronegative metals to form hydrides such as LiH, NaH, CaH2, and AiH3. In these compounds, hydrogen's oxidation number is -1 because it attracts electrons more strongly than does the metal atom.
1.
Rule number 7. The metals of groups 1A and 2A and aluminum in group 3A form compounds in which the metal atom always has a positive oxidation number equal to the number of its valence electrons +1, +2, and +3 respectively.
1.
Rule number 8. The sum of the oxidation numbers in a neutral compound is 0. Notice how the oxidation numbers add up to 0 in the following examples. Rule number 9. The sum of the oxidation numbers of the atoms in a polyatomic ion is equal to the charge on the ion. The following examples illustrate.